Hello everyone, welcome back to my YouTube channel. As you know, 2024 is a crucial milestone for SpaceX, marking a series of notable achievements for the company up to this point. SpaceX has completed many important missions, but most notably, the most impressive achievements this year are associated with their Starship rocket. While in 2023, we witnessed the first Starship launch, unfortunately, it did not go entirely as planned, encountering some obstacles and not meeting all the set objectives. However, stepping into 2024, SpaceX has made remarkable progress. They have successfully conducted several orbital flights with Starship, each flight bringing SpaceX closer to achieving their long-term goals. As SpaceX prepares for their next test flight, the scientific community and space enthusiasts are paying particular attention to the advancements the company is implementing. One of the most anticipated highlights of the upcoming test is the capability for in-orbit refueling. This is an important feature that will enable Starship to carry out longer missions, such as trips to the Moon or even further to Mars. The idea of refueling spacecraft in space is not new, but until recently, it has remained a concept rather than a technology being actively pursued. SpaceX, like with many other technologies in space exploration, has been at the forefront of making it a reality. Just as SpaceX has done with rocket reusability, an idea that was overlooked for many years before SpaceX took on serious development and testing, in-orbit refueling is now being actively pursued by the company. SpaceX's plan includes launching a Starship into low Earth orbit, where it can refuel before continuing its journey. This is a crucial strategy as it allows the spacecraft to carry larger payloads and consume less fuel when launching from Earth. To successfully carry out in-orbit refueling, SpaceX must overcome a series of complex technical challenges. One of the biggest challenges is the successful docking of two massive spacecraft in orbit. Additionally, they need to find ways to maintain the fuel at extremely low temperatures in the harsh vacuum of space and ensure efficient fuel transfer between the spacecraft in microgravity conditions. Each of these challenges requires precise accuracy, but SpaceX is working hard to find solutions to make in-orbit refueling an integral part of future space exploration missions. Notably, SpaceX has valuable experience in docking spacecraft through missions involving Dragon spacecraft connecting with the International Space Station, ISS. These precise docking maneuvers have provided SpaceX with a solid foundation, but docking two Starships introduces significantly increased scale and complexity. Starship is not only much larger, but also more complex than Dragon, so even the smallest misalignment during docking could lead to difficulties in fuel transfer or potentially damage the spacecraft. SpaceX plans to demonstrate in-orbit refueling capabilities as early as 2025. In this demonstration, one Starship will act as the target, orbiting in space, while a second Starship, known as the Chaser, will dock with the target to carry out the refueling process. This process will not only test the complex docking procedures, but also assess the ability to transfer a large amount of cryogenic fuel in microgravity, which has never been tested before. To successfully execute a mission to Mars, SpaceX estimates that multiple refueling operations will be necessary. Although the exact number is still being refined, current estimates suggest that each mission may require between 6 to 14 fuel flights to fully supply Starship before it can embark on its long journey to Mars. This means that for each Mars mission, multiple Starship launches into orbit will be needed just to ensure the mission's fuel supply. SpaceX's ultimate goal is to create a fully reusable Starship system capable of rapid refueling and quick turnaround. The company is aiming for the mid-2030s for the first crewed mission to Mars. However, Elon Musk has suggested that, if everything goes according to plan, an uncrewed mission could be carried out as early as 2027, provided that the necessary technologies and infrastructure are fully prepared. To achieve the goal of fully reusing Starship and conducting long-duration missions, SpaceX must overcome several major technical challenges. One of the key obstacles is the cryogenic nature of the fuels used by Starship, including liquid oxygen and liquid methane. These fuels must be maintained at extremely low temperatures to remain in liquid form in the harsh vacuum of space. However, maintaining these temperatures without causing significant evaporation or leakage is a significant challenge. SpaceX is researching and developing advanced thermal management systems, applying both passive and active cooling techniques to ensure proper fuel storage. Additionally, transferring fuel between two docked spacecraft in a microgravity environment presents its own challenges. On Earth, gravity helps separate liquids from gases in the tanks, but in the microgravity of space, fuel tends to float freely. This makes fuel transfer much more complex. To address this issue, SpaceX is experimenting with methods such as using small thrusters to create a slight acceleration force to push the liquid towards the bottom of the tank, aiding the fuel transfer process. They are also exploring the use of pressure differentials between tanks to efficiently transfer fuel from one spacecraft to another. Elon Musk has mentioned that while docking two Starships in orbit might not be as complex as docking with the International Space Station, ISS, it still requires thorough preparation and precise execution. Each step requires careful coordination to avoid errors, ensuring safety and efficiency in the in-orbit refueling process. In addition to technical challenges, SpaceX faces complex logistical factors in implementing the in-orbit refueling plan for Starship. Specifically, the number of fuel flights required to complete this process remains a significant question. Some estimates suggest that around 5 fuel flights might be sufficient to fully refuel a Starship in low Earth orbit, but this number could vary depending on actual conditions and upcoming tests. Some experts believe that up to nearly 20 flights may be needed to complete the in-orbit refueling process. This significant difference largely depends on a range of critical factors, including the efficiency of the fuel transfer process, the amount of fuel each refueling spacecraft can carry, and the specific requirements of each mission. For example, NASA's current estimates for moon missions under the Artemis program suggest that between 8 to 16 Starship fuel tankers might be required to provide enough fuel for a moon landing Starship. These fuel tankers would carry between 100 to 150 tons of fuel per flight, docking with an orbital fuel depot before transferring fuel to the landing Starship. This complex operation ensures that the landing spacecraft can receive the 200 tons of fuel necessary for a successful moon mission. Alongside these complex refueling plans, SpaceX is preparing to test another groundbreaking step in the upcoming Starship flight, catching the Super Heavy booster with the chopstick arms of the Mechazilla tower. This is a significant challenge that has never been attempted before. Instead of allowing the booster to fall into the ocean, as in previous tests, SpaceX plans to use the tower's arms to catch the booster as it returns. This decision stems from the success of the most recent Starship launch in June, which has given SpaceX the confidence to proceed with this test to optimize the Super Heavy booster reuse process. If successful, this mid-air booster catch method will represent a major advance in SpaceX's efforts to improve reusability and reduce costs for future space missions. In 2024, during a crucial flight, SpaceX applied a virtual simulation of the Mechazilla tower to monitor and analyze the landing process of the booster. Although the booster landed in the ocean, the data from the simulation showed that catching the booster with the tower is feasible. These positive results have increased Space's confidence, allowing them to test this method in the real world during the upcoming 5th integrated test flight. We have witnessed 4 Starship flights, and it may be just a few days away from the next flight. SpaceX is racing to prepare for the 5th test flight, officially known as the 5th integrated test flight. This flight is expected to occur at the end of August or early September 2024, depending on final approval from the FAA. Currently, SpaceX is completing all necessary pre-launch tests, including static engine burns and primary spin tests for the Starship Stage 2, Ship 30. Thank you for watching the video. See you in the next video.